Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at our string compare function, which is part of a series of functions in our core C and core H library. So in this video, what we're going to do is we're going to take a look at the ability to compare two strings, a first and a second, that are both constant character vectors. And based on whether we want to compare them as case sensitive or insensitive, return an integer value that indicates not only whether they match, which would be equal to 0, in other words, no differences, but also what order they exist in a dictionary. Now, it's important to note that in a dictionary, capital letters come before lowercase letters. So for instance, the capital letter A comes before the lowercase letter a. And then also, this is true for all the other letters. So capital letter G comes before lowercase letter g. However, though the lowercase a comes before the capital letter G. So keeping those rules in mind, what we want to do is we want to try to build a versatile string compare function that then accepts the sensitivity, either case sensitive or insensitive, as a third argument. Now, to begin with, what we want to do is we're going to make some assumptions that both the first and the second are in fact strings, which means that they must have an end of string character. So first and second must be strings. And as such, what we're going to do is we're going to use our string length function that we built in an earlier video. So to begin with, I'm going to create some temporary variables. One is going to be the first length, the second length, and we also want to create some index variables as well. We can try to get away with just a single one, and we'll see if we need to come back. So how about we have int index, and also a results, which basically indicates whether or not there was a match. Now, in this particular example, we are not going to force either to upper or lower. Instead, what we're going to do is we're actually going to loop through and compare each character. And based then on the sensitivity, we are going to determine if a uppercase and lowercase letter match. There are other ways of going about doing this. You can look at another video of mine and you'll see how we would force the case to either upper or lower to make the logic a little simpler. In this particular case, though, we're going to go ahead and compare them character by character. So the first thing that we want to do then is we want to get the length of both of our strings. So first length is equal to our string length function of our first, and then the second length is going to be equal to the string length of our second. We also want to go ahead and initialize our index. So index equals to 0, and likewise our results equal to 0. And before we forget, we want to go ahead and return our results. Now, what we're going to do here is we're going to loop through character by character in both of our strings and compare them. To do this, we need to know which one of our strings is shortest, because it's essentially going to dictate when we stop comparing. So we're going to need one more temporary variable, and we're going to call this the shortest length. And once we have returned both the first and the second length, we simply have an if statement here that if first length is less than our second length, then the shortest length is equal to the first length, else the shortest length is equal to the second length. And note that this also gets the scenario for where first length is equal to second length. Now, from there, we can either use a for loop or a while loop. I prefer to use a while loop so that we don't have to exit out of the while loop prematurely using a break, or out of the loop early using a break. Instead, what we can do is we can use a well-crafted condition here. We're going to start off with while index less than shortest length, and we're going to come back and revise this one in just a second. But while index is less than shortest length, and before we forget, we want to increment our index. What we want to do is we simply want to compare the first length, or excuse me, the first square brackets index to the second. Now, this would work just fine if we were only worried about case sensitive, but we said that we also want to handle the scenario of case insensitive. And so as such, we have a couple of ways that we can write our logic. The approach that I'm going to take in this video is going to result in some duplicate code, but will probably be a little bit easier to understand the first time through. We can then go back later on and optimize it. So to begin with, outside of the while loop, I am simply going to check what sensitivity I have. So if the sensitivity is equal to our case sensitive, else if our sensitivity is equal to case insensitive. And then lastly, our else, which should never be reached. So printf, error should not reach this unhandled case sensitivity, meant that somehow someone sent the wrong value to your function. And now our while loop here, which is going to be set up to only handle case sensitive examples, would go inside of the if branch, or the true branch of our if statement. Now, for the case insensitive, we'll come back to how we're going to handle that. The advantage to this approach is that the logic is a little cleaner to look at. The disadvantage is that you're going to find yourself writing some additional code, duplicate code rather, under the else if. If you were to move this if statement inside of the while loop, you would be checking the sensitivity every time the while loop ran. While that would result in more compact code, it would also result in some additional unnecessary checking, because the sensitivity will never change inside the function. So while this duplicate code may be a little unwieldy, it is also the most efficient in this scenario. All right, so continuing on, while the index is less than the shortest length, we simply compare the two values. And if they're equal, we move to the next character to compare. Else, we simply change match or results equal to something other than 0. However, if you recall earlier, we had some specific values that we wanted to use to compare or to return the results of our compare. And we said that we would like to ultimately determine not only if there are no differences between the two strings, but also the order in which they would exist if they were in a dictionary. And so we're going to start by looking at the case sensitive example. And that what we would do is we would take a look at the first and compare it to the second. And if it came earlier in the dictionary or came earlier in the ASCII table, then we would assume that it would come earlier in the dictionary. At this point in the video, it would probably be useful if you pulled up the ASCII table on Wikipedia and remind yourself of the decimal values that are associated with the capital letters A through Z, as well as the lowercase letters A through Z. And a quick reminder should tell you then which letters come first. So for instance, the capital letters would come before the lowercase letters would in the dictionary. Therefore, what we could do is instead of doing a direct comparison, we could simply compare, for instance, our first index. And if it was less than our second square brackets index, then we would simply say results are equal to -1. And this means that the first word comes before the second word in the dictionary. If we were to follow this up with an else if, we could then look for first square brackets index greater than second square brackets index. And if this were true, we would simply say results are equal to a +1. And then the only other possibility would be if first square brackets index was equal to second square brackets index, in which case our results would still be equal to 0. And technically, we would not need this line right here because that is our default value. So I'm going to go ahead and delete our first attempt at this. Hopefully you can understand here that if the results are equal to -1, first comes before second. If our results are equal to 1, that means first comes after second. And then if our results are equal to 0, keep on matching. Which brings us then to the while loop and the compound condition that we need to check that not only our index is less than the shortest length and our results are equal to 0. And once again, you could check the results first. Either is fine in this scenario. However, when we get done or when we have exited our while loop, then we need to evaluate once again which one of these two words comes first. Why do we need to do that? Well, because we have only compared the words up to the shortest length. In other words, if you think about the scenario where you are comparing the words ham and hamster, we would only compare the first three letters, and therefore a ham and a hamster would be the same word. Clearly, that's not the case. So what we need to do is one last time, we need to check if the results are equal to 0. Then we also need to check which is longer. So if, for instance, our first length is less than our second length, then this means that our first word is shorter than our second word, in which case it comes earlier in the dictionary. Ham comes earlier than hamster in the dictionary. So once again, the first comes before the second. We need an else if then to look at if first length is greater than second length. And if first length is greater than second length, we would simply assign results equal to 1, which means that first comes after the second. And then, of course, the only other possibility would be that the first length is equal to the second length, in which case results are equal to 0. Once again, this simply reinforces our default value. At this point, though, we can guarantee that the two strings are equal. Now, note there is one scenario here that you would probably want to consider handling, and that is the scenario in which both the first length and the second length were equal to 0. You could argue that two empty strings are equal to each other, in which case this would handle that. Now, let's take a look at case insensitive. There are a couple of ways that we can handle case insensitive, but probably the easiest way to do so would be to create another set of temporary variables, in which case we're going to add two more up here. This time they're going to be of type char. And so we're going to call the first one first char, and the second one is going to be second char. Now, just like in the case sensitive example, we are going to go ahead and set up our while loop. None of that really changes. As a matter of fact, it's actually, we can benefit from the earlier example by essentially handling the results equal to 0 now. So we can say while index less than shortest length and results equal to 0. Now, where this is different is in the use of our temporary variables. And so to begin with, what we're going to do is we're going to have a little bit of logic here. So we're going to say first char is going to be equal to simply nothing more than first square brackets index. So we're going to use this temporary variable, and we're going to do the same thing now with the second char. And there is a way that you can get around doing this. It just requires a little bit of finesse with your vectors and with your temporary variables. But at this point, what we want to do is we want to remind ourselves of the ASCII table again, and particularly the ranges for the capital and lowercase letters. And so you'll note here, if we aren't interested in case, we can essentially shift everything to uppercase, or we can shift everything to lowercase. If we want to shift everything to lowercase, we simply add 32 to a value, but specifically not any value. Specifically, we want to only add 32 to values that are from 65 to 90. And so what we'll do here is add a little logic inside of our branch here, and such that if our first char is greater than or equal to 65, and first char less than or equal to 90, what we want to do here is we simply want to say first char is equal to first char plus 32. And so what we're doing here is we're essentially just artificially shifting everything from uppercase to lowercase. Likewise, we're going to have another if statement such that if second char is greater than or equal to 65 and second char is less than or equal to 90, well, we do the same thing. We simply shift the second char up by 32. Now we are guaranteed that all uppercase letters are their lowercase equivalents, at which point we can continue with the same logic that we had earlier, where we simply compare our characters one by one. So in this case here, we're going to say if our first char is less than our second char, then we simply say that our results are equal to -1. Else, if our first char is greater than our second char, results equal to 1. Else, results still equal to 0. And I'm not going to put the extra comments in here, but essentially this just means that your first comes before your second. Results equal to 1 means that first comes after the second. Results equal to 0 mean that they match. And at which point then we simply loop through all of the characters in whichever one of the word is shortest. And if our results either wind up being something different than 0, or we run out of characters to look at, we come out of our while loop, which means that we want to check one more time if results equal to 0. And then we have some special cases that we need to check, and that is going to be if our first length is less than our second length, then our results equal to -1. Else, if our first length greater than our second length, then results equal to +1. Otherwise, results equal to 0. And once again, you don't technically have to have that line there. And as I mentioned earlier, we still have this scenario under which we would have 2 empty strings, and they would technically match. All right, so let's go ahead and build it. Let's see if we've got any mistakes. And then let's go up to our main and build a driver for this. All right, so we'll leave it here at our string compare. We're going to go over to our core driver. And we'll come up here to our main. Just like in our earlier examples, we're going to go ahead and create a new switch combination here. So else if, and let's think about this now. We're wanting to compare two strings. And then we also want to specify whether it's sensitive or insensitive, and specifically case underscore sensitive and case underscore insensitive. So you're actually going to want to provide it the executable name, the string compare switch, two strings to compare, and how you want to compare them. So in this case, our arg count is actually going to be 5, and we're going to compare using string compare I. Our argv square brackets 1, and if it matches our slash string underscore compare, then we're going to assume that we've got something valid in the other arguments, in which case then we probably should consider having a additional set of temporary variables. But in this case, I'm just going to go ahead and pass my argv2 and my argv3, but argv4 is going to require a little bit of extra logic here, because we need to be able to pass it as a case sensitivity type, not as a string. And so to be able to handle this, what we do is we have another if statement. So if string compare I, if we compare our argv square brackets 4, and we compare it to case underscore sensitive, it's up to you if you want to use the slash or not. That's perfectly fine. And if that's equal to 0, what we want to do is we want to make a call to our string compare function. We want to pass to it argv square brackets 2, which is the third argument. And we want to pass to it argv square brackets 3, which would be our fourth argument. But most importantly, if it is case sensitive, we want to pass to it the case sensitivity type case sensitive. All right, so we probably, let's see if we can get this to highlight here. So there's our core.h. Make sure that I've got this spelled right over here. Let me just come over here and borrow this. Yeah, there we go. Let's make sure that we have this enumerator. There we go. And then just like before, what we want to do is we want to print f, and in this case, probably we will maybe throw in a little bit of logic here. We can get quite fancy if we want to, but at the very least, what we would do is print our results, the %d, followed by a new line. And we'll just simply print our results for now, just to make sure that we've got this working. And then under the else if branch, we can once again use string compare I. And we want to compare argv square brackets 4 with case underscore insensitive. And if that is equal to 0, we will essentially run our string compare function. However, this time around with the case insensitive enum. All right, once again, we'll come back and we'll finish this up a little bit. At the very least, what we can do is under our else, we can probably just make a call to help, which means it probably would be useful to update our help And that down here, throw in a couple of extra examples here. And that is going to be our string underscore compare. And we want to compare two strings. I'm going to start off with the example that I had earlier, ham and hamster. And we want to compare them case sensitive. We're going to have quite a few examples here that we can try out, but we just want to provide a couple to the user here for their documentation. And so how about if we do it case insensitive, and we will capitalize our ham in both scenarios. And I tell you what, why don't we do this? We'll do it this way, hamster and hamster. All right, and let's see exactly which one of these work. So ideally, if it was case sensitive, the capital hamster is going to come before the lowercase hamster. And even if we were to just do it this way, it should as well. So that probably seems like a good example to include here. All right, so let's go ahead and build it. Let's see if we've got any mistakes. Probably the first thing that we want to do is just simply run our help just to make sure that that still works. Good, look positive. All right, so we'll do string compare. And we'll follow the instructions here. We'll pass hamster and hamster. And we want to do case sensitive. And sure enough, the capital H hamster comes before the lowercase hamster. And then let's do case insensitive. All right, so we've got a problem here with the insensitive one. I think I know where the problem is already, because based on this delay right here, it looks like I'm running an infinite loop. And so let's go ahead and hit Control-C a couple of times, get it to break out. I am almost willing to bet that I forgot, as I normally do, to increment my index. We did it in the case sensitive, and I'm going to bet that I forgot to do it inside of my insensitive. All right, so there we go. It's always good to go ahead and do that early on, because invariably you're going to forget. All right, so let's rerun the insensitive one, and sure enough, the results are 0. Let's now see what happens when we're comparing a ham to a hamster. And when it's insensitive, the ham still comes before the hamster. And when it's case sensitive, as we would expect, the ham comes before the hamster. And now let's look at a couple of more examples here. We're going to say hamster and hamster. When it's case sensitive, it's going to be 0. And hamster and ham, when it's case sensitive, it's going to be 1, because hamster should come after ham. And then also when it's a capital H, it's going to result in 1. And then the last set that we want to look at is going to be the case insensitive. Once again, ham should come after hamster. Or excuse me, rather, hamster should come after ham, which we have our results 1. That is correct. And likewise, the hamster comes after the ham. All right, so looks like it's working correctly. So hopefully you found this video useful. There are definitely places to improve the code. Once again, not bad when we only have a 1 error here. I like to see errors because it gives us an opportunity to do a little troubleshooting. Nothing works out perfectly the first time. Hopefully you found this video useful and you've added this now to your core.c. As always, don't hesitate to email me if you've got any questions or comments. Thank you for watching.